Hello everybody. In this video we will talk about finding the general solutions to some simple differential equations where the relation between the function and its derivative is explicit. So we'll go through two examples. Let's go ahead and take a look at the first one. And it's something that you have already done many times. We're just looking at it slightly from a different perspective. So let's say we have y prime of x is equal to 4 tangent 2x minus 3 cosine x. Okay, it is a simple differential equation. Okay, the first derivative of the unknown function is given to us explicitly just in terms of x. So this is the easiest type, and all we have to do is just integrate. So y of x is the integral of y prime of x dx. Okay, so what do we get? This is the integral of 4 tangent 2x minus 3 cosine x. And at this point, we've integrated tangent enough times to know what that is. This is the natural log of absolute value of secant 2x, right? And by the chain rule, it would be 4 divided by 2, so the constant is 2, minus what? Minus 3 sine of x and plus some constant c. Okay, so finding the general solution to a simple differential equation of this type is easy. We just integrate it, right? So you look at the expression over here, and there is no y here or some relation of y. Everything is in terms of x, and we just integrate it. Okay, so let's take a look at example 2. Example 2 says, now we have a second derivative, y double prime of t is equal to 15 e to the 3t plus sine of 4t. Okay, so what do we do? Again, I'm looking at my differential equation. On the left, I have the second derivative. On the right, I only have expressions in terms of t. Okay, so we need to integrate this twice. For the first integral, we get y prime of t. Okay, so y prime of t is the integral of this expression right here. Okay, everything is straightforward to integrate, so this is 5e to the 3t minus 1/4 sine, nope, not sine, cosine of 4t, and let's say plus c1. Okay, so that's the antiderivative of y double prime. Okay, so then y of t is the integral of y prime of t, right? So this would be the integral of this expression 5e to the 3t minus 1/4 cosine of 4t plus c1. Okay, so this would be 5/3 e to the 3t minus 1 over 16. Oh, doing it again. This is sine of 4t plus c1 times t and plus another constant c2. Okay, so this is your general solution, right? So this is your general solution to the differential equation. Okay, so these constants C1 and C2, you might be asking, well, what are they? Well, that depends on the initial conditions. Okay, so notice that in this particular video, we have these constants floating around. So here's C, for example, 1, and over here we have 2 of them, C1 and C2. Okay, these are general solutions. So in the next video, we will discuss solving differential equations with initial values where these constants will be found explicitly. Okay, thank you for watching.